Mason Reynolds, and they said that their mom went snowboarding or skiing or something. I said, "Oh, is your mom in the Olympics?" And she said, "Yeah." And she just nonchalant said, "Of course, yeah." I was like, "Wow." You don't know what you're talking about.
All right. Today we're going to look at just a few word problems. So we're on page 284 on problem number 59. That's what we're looking at, and we're going to look at this one has more than one piece. And then we're going to look at two other word problems, and we're going to be using some features that you may not have used in a while off of your 84s, and we're also going to be using some features off our 89s. So if you don't have both of those out, you may want to pull both calculators out because the two different lessons need two different things. 284. That's because that's what he said back there, approximating the page number. All right, so with problem number 59, let's see what the setup for this question is about. Modeling data. You know, when it says modeling data, that's usually because it gave you a table and they want you to do something with those values. It says a life insurance company needs a model to approximate the death rate of citizens during the years that they are in the workforce. The table gives the death rate R per 1,000 for the individuals at age X. So when you have 20 in the table, R being 1 means 1,000. I mean, 1 per 1,000, excuse me. And when you say 30-year-olds, it's 1.4 per 1,000. And as it goes up to where 60-year-olds, it's 11.7 per 1,000 people. So that's obvious. As you get older, more people die. Now, in Part A, it says use the graphing utility to plot the graph and the data and the graph of the model. So then it gives you this model here that represents R equals. And so what we're going to do is two different things to get it to do this. First, why don't y'all go ahead and Y equals, type in that R equal to formula. 80, yeah, let's do 84 because I don't know if the 89s will be really good for this or not, for this particular part. So we're typing it in Y equals. You type in the R formula in, yes, and Y equals. What's backwards? Oh, the formula? Yeah, I don't know why they do that. Sometimes they'll put the formulas in a different format than we're used to. And to me, I don't know why. I think it has something to do with that square root. Yeah, I don't like math print myself either. Plus 45. Oh, I got too many zeros. I'm going to have to go back and take one of those zeros out. I think I picked up an extra one by mistake. Square root. What?
A little indentation in my forehead.
Oh.
It feels really cool.
Alright, I don't know if I typed mine right or not, so we're all going to proof our equations that we've typed. So when you get your equation typed, go to second window and tell your table to start on 1. And we're just going to check to see if the first 2 or 3 numbers match so we'll know if we typed our formulas right. I might have typed it wrong, so I don't know. That's why I'm having us all match up. So 1 says 45,697. Anybody got that?
I got negative 51. That's
Yeah, I
right.
got negative 51.58.
Okay, what did I do wrong? Okay, I might have missed a subtraction sign, so let me go back and check. Negative 0.91.1, right?
Yes.
Minus 6.313x.
Yes.
Okay. plus 0.035x squared
Yeah.
plus,
Oh, you're
Oh,
missing
you
your,
forgot decimal.
your decimal.
right there.
45.794.
Okay, thank you. So that's why we're just going to compare. 45 point. Okay, now let's compare again. Now do my match yours? Okay. Now, the second thing we're going to do is we're going to put the data in. Now, to put the data in, you go to the Stat button and go to Edit, and you're going to type the first row in L1 and the second row in L2. So you got to type 20, 30, 40, 50, 60. Yep. All right, so you're putting your data in. You've got your L1, your L2 thing going on. Now, one of the things that they want us to do with this is to use our graph interior to plot the data and graph the model. And so my thought was, I wonder if all of these data, how much the data fits the model, which is why we're putting in both. Usually, you don't have the model and you do stat calc and get your own equation, but they gave us the model because we don't have a way to stat calc and get a square root in our equation. So we got to go second y equals so that we can turn on a plot. So we're going to turn on number 1, so press a 1 and turn it on. And pretty much everything else here is good because we want a scatter plot, which is the type. We want L1 and L2 used, and we want the biggest thing we can see for the points, so that would be this little box thing. Now, we need to set our window because we don't want to just zoom. We want a window that makes sense. But we want our window to make sense as though we were going to be graphing this by hand. So this is what I'm going to let y'all do. Here's talk this out. What number should be on the x-axis if 20 to 60 is in my table, but I have to make an xy axis, and graphing? 0 to 60, okay. So then put 0 to 60 for the min and the max on the x. And what should we go by? Well, the table's going by tens, we might as well. All right, everybody put that in. 0 to 60 by tens. Now, for our R values, going up the y-axis, what should we go from what to what and by what?
0 to what? 12.
Okay, by what?
1.
Okay, we could do that, or
21.
you could do twos. You can do ones or twos. Either one of those would be a good scale. So y minimum is 0, y max is 12, and you can go by ones or twos on the y scale. All right, and then you just hit the graph button. So my question is, when you hit the graph button, is every one of those points on the curve or any of them a little off? There, because somebody stat calc this to get this equation with a better calculator than what we have, and got you this equation for the problem. So it fits pretty good, but not perfect, is it? Okay. Now, let's talk about when you're doing a problem like this, what would you write down for the answer to the question? Because it said use a graphing utility. Well, so we have 10, 20, 30, 40, 50, and 60 down here. What do those numbers stand for? Ages, okay. And then up the side, you said you want to do ones or twos. So I'm going to do twos because it'll take less paper if I do. And what do those numbers up the side stand for? Death rate what?
per thousand.
Per thousands, that's right, per thousands. So when they say, 2.3, they mean 2.3 people died out of every 1,000. All right. Now, I want you to plot the data based on this. When you look at your calculator and you go to table, it would be helpful if I had set my table up to do that. No, tens. I'm going to start my table on 0 and go by tens. And now I understand why they didn't have anything before 20. Do you? So what you will do is you will plot these values from 20 to 60 and curve them in. And then you'll go back and plot, maybe with an X, the values out of the book to show they're a little off. Does that make sense? Okay. Now make it look as much like the calculator graph as you can. So you'll plot these because these are the real values for the equation you've got. But then you'll plot the other ones because 60 on the other one is 11.7, so this is a little low. And 20 was 1, and that's a little high because that's what 30 was. So it all kind of evens out. Some of them are a little low and some of them are a little high, and it fits to the curve pretty good though. So I'm going to pause the video while you make your graph. Alright, so let's look at part B. In part B it says, find the rate of increase of the death rate from 40 and from 50. So the age 40 and age 50, we're going to be looking at what is the actual death rate increase. Now, that means when you ask you to find a rate of a rate, that you're doing a derivative. Does that make sense? I already have a rate, and they're asking me to find a rate of increase. So that means I have to be looking for a derivative. So we go through and we make the derivative formula. R prime of x is equal to, well, guess what? Constant drops away. The linear drops x, so those two were easy. The 2 comes out in front and makes it 0.07, don't it? If you double 35, it'll be 70, and then put the decimal back in correctly. Is that right? And then the last one, if you put the half in front, and it goes to negative a half, 22 point what? 897. And I'm just going to leave that negative a half there for the moment because this is all going to be calculator active, so there's no reason to move it down and make it hard to type in the calculator. So now that we've done the derivative, we can find the rate of increase of the original rates. And it says to do 40 and 50. So all you're doing is plugging in 40 and plugging in 50. Now let's talk about the units before you do the calculation. It's already going to be death rate in thousands. And now we've done a derivative. What do you think the units now represent? Anything different?
I think it's different, but I don't know what it is.
It's the increase. It's how much it went up. The rate went up. The units on the actually are still per thousand, but it's how much the rate went up if you're age 40. So, like, for example, at age 40, the number of deaths increased blank per thousand. That's kind of what I'm talking about. It's more about how you describe the answer and less, well, I'm going to just turn that into a sentence, put a capital letter on it, and less about the units changing. The units really didn't change. It's more how you describe it. This answer is going to come out positive. That's why it's an increase. If it had come out negative, that would mean it's a decrease.
I got 0.1073 for 40 and then 0.4251.
Let's do a 2 decimal place answer.
So
Everybody agree with that? 0.11 and 0.43. So at age 40, there's really not a great increase per thousand, not even a whole person. It's not even increasing a whole person per thousand for either one of them. But this definitely is a lot more at 50 than it was at 40, because as you get older, the rate of death is going to increase.
So almost half died.
Yeah, that's like got 2.4 children. That's more than every household in the United States. Now, let's look at Part C. Find the average death rate for people between the age of 30 and 40 and for people between the age 50 and 60. And they're both done pretty much the same way. It's not really a big difference in how you do it, but it is something you want to use your 89 for. Okay? So let's talk about, what does average mean? When we've been studying this already, what does average mean? When somebody tells you to find an average in this chapter, what is it telling you to do? Integrate. And when we integrate, we're finding average value. So to find average value, you remember you have to do b minus a over the integration from a to b of your function dx. Everybody agree with that? So what's a minus b in Part C? Both of them are how far apart? From 30 to 40, or from 50 to 60 is 10. So this is 10. And then you set up your integration from 30 to 40, and you're going to put your formula in here. And then you're going to do the same thing again, and you're going to change the numbers from 50 to 60. Now on your calculator, when we're not writing all that formula out because it's the same formula for both of them, right? Everybody agree with that? So when you put 1 over 10 in your calculator and hit the integrate button on your 89, you're going to type the original equation for R, not the derivative equation, the original equation, because it's asking for the average death rate, not the average increase in the death rate. Do you see the difference on how you know which one to use? And then when you get done doing 30 to 40, you can just change the two numbers on the end where you do comma x, comma 30, comma 40 to 50 and 60. So I'm going to give you all a second to try that. Don't call out the answer. Give everybody an opportunity.
So would you put the integration and then times it by 1/10?
Uh-huh. Yeah. Well, I usually put the 1/10 out there in front of it.
Okay, so you can do that.
Uh-huh.
Actually put in education symbols, but
Yeah, it does not like it if you don't put the times marks.
it says that you imply it.
Right.
I always forget that.
Comma x, comma 30, comma 40
Okay, at the very end of
at the very end before you hit in the parentheses. Mm-hmm.
I've been using that so much. And then at the end you put comma x, comma
30, comma 40. Mm-hmm. Now you're finding out the number of people who die. Okay? That's what you're finding, the average number of people who died in these age groups per 1,000. You see on the table, 30 to 40 went from 1.4 to 2.3. That's not quite a difference of 1, right? So when you do the 30 to 40 here, what does that round off to with a couple decimal places since we were doing a couple earlier?
over 1.
It is over 1. 1.80?
Yes. Okay, so 136.
So the average death rate is 1.80 per 1,000, which makes sense because when you just look at the numbers, it's 1 almost. What'd you do?
I think I put some bleeding where they weren't supposed to be.
Ah, that does play a part. All right, so now when we're doing it from 50 to 60, the original problem showed from 4.7 to 11.7, which is a 7-point difference. But when you do the math, it comes out a little more accurate to be 7.35. Is that what everybody's getting? I don't know, it's a little bit more of a talk about death rates, y'all, but it's a factor of life. We're all going to be here till we die, so we might as well learn something about it. All right, so as you can see, the death rate jumped up tremendously the older the people got because health is not as good, or they didn't take care of themselves. You know why the majority of people don't live as long as others do? Like, you get a few people in your family that might live to be 80 or 90. Why do you think that is?
Because how they take care of their bodies.
Yeah, it might have a lot to do with that. And not necessarily, Ethan. My daddy's 92. He don't smoke and he don't drink. And he's surviving pretty good.
You know what I'm saying? Because, like, if you did smoke and drink, you would.
Well, not necessarily. Some people who smoke and drink did it in moderation, and they might be healthy otherwise. No, not necessarily. If a lot of times things like smoking and drinking and things like that, if you did a lot less of it, it's not as bad for you as if you did too much of it.
Depends on what you.
Right, it does also. So, but the thing is the majority of the people who actually do that ate healthy, and they didn't, worked out. They worked out in the fields, and they worked off all that cholesterol that we're not working off.
Also, the people that
Like, I have an uncle that lives like in Arizona, and he buys his tobacco from like Indian tribe that lives near him, and
Uh-huh.
he gets paid for coals on cigarettes.
Uh-huh.
Nothing else.
Right. It does make a difference. With years ago, the cigarettes weren't quite as bad for you because they didn't have all the chemicals in them. But again, it's really not good to do either one of those things. It's a matter of, you've got the healthier you try to take care of your body, the better off you'll be. All right. Well, let's look at 63.
Like, humans have a certain age you can't live past, like, physically.
Right, because eventually it does give out because it deteriorates.
Yeah, that's not how, like,
Making it up to 100 is an unusual thing.
I think when I was taking anatomy, they said that humans can't get over 125.
Yeah, I've never known very many people to get over 120.
Yeah.
All right, let's look at number 63. Remodeling department store manager wants to estimate the number of customers that enter the store from noon to 9 p.m. So he has a table down here that represents the number of customers entering the store, randomly selected minute each hour, from T-1 to T, where T is 0, represents noon. So he's got T representing the hour and N representing how many customers came in. And we're not going to make a histogram because that won't really help us do calculus. So we're going to skip part A. It says estimate the total number of customers in the store between noon and 9 p.m. So, I sure wish I had wrote more on my paper because I would know a lot better what I'm doing here. All right, so that's an 8-hour period. Everybody agree? And during that 8-hour period, they selected a minute from each hour to calculate up this information. Okay? So when they say 1 is 6, that's 1 minute. Well, what happened to the other 60 minutes during that hour? Yeah. So there's something we might want to think about as we go through this question. So first, let's just look at the data itself. Could you find the total for N? All right, everybody calculate up their total. Don't need to call it out. Just everybody add it up while I figure out why I got this number on my paper, because I didn't show all my work. Yeah. Okay.
about the smoking and drinking thing.
Mm-hmm.
My grandpa smoked like probably almost a pack a day for 55 years. And I'm like, how could you do that to your body?
I know, I'm thinking the same thing. All right, everybody's got their total, right? Now that's 1 minute in each hour. Okay? That's the total for that 1 minute for each hour for the whole 8 hours. But there were other minutes. So like, for example, during that first hour, we could say that every minute of that first hour, at least 6 people came in. If 6 people came in on one of them, to estimate. Does that make sense? So how could I convert this into this total? How could I convert it into how many customers for the whole 8 hours? That's right. So what was your total? 83? All right, we're going to times it by 60 to find out the total number of customers for 8 hours. How much? 4,980 customers. So the key here is that's just kind of a rough estimate. Does that make sense? It's not exact. It's just a rough estimate. We're assuming that every hour the same number of people came in during that first hour were all 6, and the second hour was all 7, and so on. That's not realistic.
Where's the top of that? Is that X to the 60th or X times 60?
X times 60. That means a times mark 60.
Something times 60.
Yeah, 83 times 60. All right, now let's look at part C. It says use the regression capacities. Is that what that is?
Capabilities.
Thank you, capabilities. Can't see today. Use the regression capabilities of your graphing utility to find the model for the form n sub t equals, and you'll notice the highest power in that's cubed. So this was part B, so now in part C, you're going to try to find your formula by using StatEdit StatCalc. Okay? You're going to do StatEdit and you're going to type in the information, and then you're going to do StatCalc to find a cubic equation. Yep, you got to put the whole entire table in L1, L2. You can just type over whatever's already in there, because that'll work if you just type over it.
And we put this formula in y equals, or is that not necessary?
No, we don't need to be in y equals, because I'm not going to graph this one. We graphed one, so I'm trying to do different things on each one. All right, so we're doing StatEdit StatCalc cubic so we can get the equation, because maybe we might want to differentiate or integrate it or something, you know, and we need a formula, and there's no formula given with this question like there was on the last one. So we want to be able to come up with our own formula, and that's why they told you to make it of this format, because they figured you know that looks like a cubic.
Cubic regular?
Yeah, cubic reg. Cubic reg means cubic regression.
Yeah, I got
Now, if I was wanting to graph it, I'd have to do something extra, y'all, because when you do StatCalc, like when you do a StatCalc, like this cubic, for example, mine's not going to do the right thing. Did y'all's come up like this?
it. Yeah, go to calculator. Okay.
Well, what I was going to say is, if you were wanting to graph it, then when you get down here to store reg, you'd actually want to type Y1 there, for example. Now, I don't have the right data in, but you come over here and you go to Y bars, and you pick number 1 function and tell Y1, and it types the Y1 there. And why that might be important is so that you don't have to go type the equation in that it just made over there in Y1. So if I actually really did want you to graph this, that would be a great way to pull in the equation without having to type all those decimals. Does that make sense? All right, but I can't hit calculate because I don't have the data in. All right, so now, whatever you've gotten on your calculator, did you get nice numbers or do they need some rounding? Okay, all right. Well, let's round to 4 decimal places so we can have a little more accuracy. Okay, so write out your equation for n sub t and round each decimal to 4 decimal places. I wish we could have done this on the 89 because then we could have been able to have the equation with all the decimal places to do the integration or differentiation or anything like that we want to do. But tables don't work as well with the 89s. I still can't figure out how to make them work good.
I don't entirely understand that.
What we're doing?
Yeah, with this part.
So you're going to round that off to 4 decimal places and put it in front of the cube for A. Then you're going to round that off to 4 decimal places and put it in front of the x squared and so on. You're writing down your formula. You're putting the A, B, C, D in front of each term where it goes. And that was the format of the question in the book. They actually had A, B, C, D written that way.
Now, what is that?
What's what?
Like X. Yeah, I think 8 times X.
It's T.
Or T. It
But-
says X in the calculator.
Yeah, it's T. The T's in this, they stand for time. So you want to put T's in there, not X's. And we just have 2 small calculations left to do, but we'll have to use our 89s for that. That's why you need to get this equation written down. Is somebody at the door?
No, they're working across the hall.
Okay. Now we're going to set up E and F, and then I'm going to let y'all go to working on your calculator with it. All right, so you've got an equation that's got a cubic, a quadratic, a linear, and a constant term in it, and you've rounded them off because we can't write all those digits down. That'd be ridiculous. Now, yeah, I'm skipping D. We plotted on one or the other, so I'm just trying to do different things. It says use the graphing utility to evaluate 0 to 9 of n sub t dt so that the results would be from noon to 9 p.m. Compare this with your answer in B. So we got that answer in B that was 49.80, right? That's how many we thought. If we made every minute of the hour the same numbers. Now they're saying really do the math. To integrate the formula that you just got from 0 to 9. Because 0 represents noon and 9 represents 9 p.m. Now let's set up part F also. That way you can do it all at one time. Part A says, estimate the average number of customers entering the store per minute from 3 to 7. So first of all, they used the word average. What does that tell me? That's right. Now, and what number would I need this time to go from 3 to 7? 4 hours, right? And then we'll put 3 and 7 on here because 3 represents 3 p.m. and 7 represents 7 p.m. So the formula that you just wrote down on your paper for the answer for part C is what you're putting in the integration to integrate it with. And you can put X's in the calculator if you'd rather on your 89s, because I know it's not comfortable for us to type T's, although there is a T button. So this first one is going to find the total number of customers that we can compare to that 49.80, and the second one's going to find the average number of customers per minute. Don't call out the answers. Give everybody a chance. So this part here on E is kind of like using the first fundamental theorem of calculus, except we're doing it on the graphing utility instead of doing all the math by hand because of the decimals being so nasty. But that's the first fundamental theorem of calculus. This is average value theorem on part F. All right, is everybody getting some answers? All right, what'd you get for E compared to the 4980 customers from part B?
85.
Anybody getting that?
I think it's compared to the 83.
It's compared to the 83? Okay, that would make more sense then, based on the answer we're getting. So this is comparing to the, before we multiplied it by the 60, that it was 83 as a total for all those minutes, but then it comes out 85 because it's just going to be a little bit more accurate. We're using, now it probably might have come out more accurate if we'd use all the digits and the decimals, but unfortunately that's too many to type in. Yeah, let's multiply that by 60 and determine with our 85 times 60, what would that come out? 5,106. Oh, that'd be 7. So it was a lot closer when we just talked about those minutes. But when we multiply it by 60 to turn it into the 8-hour period, it's off more, isn't it? Off quite a bit more. All right, so our last one, you're going to go back to your problem, and you're going to insert this 1/4 in front of the integration and change your integration to 3 to 7 to see what the average number of customers entering per minute, and how I know it's per minute is because it's a rate. It's the number of customers over your time unit, and our time unit is by the minute right now. And this is relating back to the chart being that it's 6 customers in the first minute and 7 in the second minute and 8, 9 in the third minute. What's the average amount coming in? Because as it went up through the day, it kind of got up larger, and then it started going back smaller closer to closing time. So you have your busy times and you have your times that are not so busy. And all that averages out to give you so many customers per minute.
It's weird.
Oh, we might need to change this 4 hours over here then, if this is going to be in minutes. Let's put that as 240. And then we can all be in minutes. Good point. Thank you for noticing. Yeah, we said 3 to 7 is in 3 to 7 is in hours, and this was in 4 minutes. We got to multiply by 60 also, don't we? Because we've got to change it to minutes, like we did on the last one.
Well,
So let's convert it to all the minutes. So it's 1/240 because that's where 4 hours is. But we're still integrating from 3 to 7 because that's hours.
well, if you change that to 240 and then you multiply by 60, you might as well just multiply it by
That's just, exactly. Oh, well, yeah, yeah.
Same thing.
Well, great. Then if we didn't have to convert. I knew that, but I wasn't going to tell y'all. Did you get this? Oh, no, 6. I can't read my own handwriting. Is it 12.6 approximately? So about 13 customers a minute? Yet, at closing time, if 13 customers came in, I'd be freaked out. I'd think they were ready to rob me. Wouldn't you? All right, so tonight I want you to work on page 284, and I want you to do 58, let's see, 62, and 64. I was going to sign 60, but I thought that one seems weird. It's got a K in the formula that stays a letter for a constant, but we don't know what number to put in for it, so I think I'll skip that one. That seems weird. So 58 and 62 and 64 on page 284. All right, again, tomorrow is your quiz that we're doing over, and we're going to do all of it over at one time. So do y'all want to go over the questions on the back of the quiz today? Because I can keep recording. Okay, we'll do that real quick. Let's see, what was on the back?
That was the second thing.
No, this
Yeah,
is the first.
the first fundamental theorem, I thought. Yeah.
One I feel okay with, as long as I remember to start the first two and the last one.
Uh-huh. Now, my problem is I don't have my copy.
Do a phallic symbol. I'm erasing.
So, if you can tell me which questions y'all need help with, I'm going to pull up the document and we'll look at those. So we're looking at the back of the quiz because you said you had questions about the back.
This needs to have locate questions on paper.
Oh, locate questions on paper. Okay. You look at your paper and see which ones have an X next to it. 7, 8, 9. So we didn't have trouble with number 6. We're okay with number 6.
Well, just go over any of them.
Okay.
I'll find a common theme.
Okay. I can also go back if you just want me to look at one of yours. I can look at yours.
Because I do see a common theme, but it's not one that's helping me.
Oh, okay.
I don't see why when it was a minus in the calculator, it gives you infinite figures.
Okay, it should not. All right, so first of all, the cube root of t, if you add 1 to the power, it becomes t to the 4 thirds, right? But that makes it 3/4 in front. And then negative 2 becomes a linear. Because if you add 1 to 1/3, 1 and 1/3 is 4 thirds, right? And then you flip it and put it in front 3/4. And you're supposed to do that from negative 1 to positive 1. So positive 1 put in that problem is just going to be those two numbers. Because anything to the 1 to any power is 1. Right? And 1 times anything is 1. Subtract putting in negative 1. That's the trick. So we're going to look at that negative 1 part because I'm thinking maybe that might be where y'all made your mistake. So when you put in negative 1, you do the root first. The cube root of negative 1 is negative 1. But negative 1 to the 4th power is positive 1 because it's an even number. And then 2 negatives make a positive. But that has a subtraction sign in front of it. Everybody agree? So when you distribute, these two cancel out, and negative 2 and negative 2 make negative 4. Anybody get that one right? So I'll know if the answer's right.
So wait, how did you get the powers?
Okay, how do I work the power out?
No, wait, how did you just get the top power?
This one? 1/3 is what that root is. If you add 1 to it, that's 1 and 1/3, and 1 and 1/3 is 4 thirds is an improper fraction.
I had one moment, I just added 1 to the 1, and so I just put 2 thirds.
Okay.
I got a negative 9/7 minus 9/4.
Well, first of all, it has to be a negative here somewhere because the fractions are supposed to drop out. So even if you got a common denominator, you wouldn't get 9. Maybe you did 3 plus 3 is 9. I don't know.
Wouldn't 1 times negative 2 be negative 2?
No, because this is a negative 1.
Yeah, I got a plus.
And then you distribute your negative that's between the two of them. That turns it back negative.
Yeah, so I got negative 7 divided by 4 minus 9 divided by 4.
Well, this is 8/4, and 3 minus 8/4 is negative 5/4. And this is both negative, so you'd add them, and that'd make negative 11/4. And 15 and 11 make negative 16, and negative 16 divided by 4 is, well, I left my negative off, but it's negative 4.
Yeah, I can always answer it.
You probably just did it in a different way in terms of putting the numbers together, which is fine. All right, let's look at number 8. Hopefully that writing won't come back that I just...
I would got this right if I could.
Yeah, the negatives are always the downfall. All right, whose derivative is secant squared? Tangent. And whose derivative is negative sine?
Cosine.
And how I know what to do with the cosine is this. I keep this negative and think about it and say, well, this already starts with a c, so that puts another negative, and two negatives cancel each other out. You have a negative already. The word that starts with a c always puts a negative, so two negatives cancel each other out. So now we're going to do our interval. And a third is more than a fourth, right? So it's in the right order. So you're going to do the third first. I think some of you made a mistake on what that was. I don't think you messed up the pi over 4 one. I think you messed up the pi over 3 one. But I could be wrong. Because the cosine of pi over 4 is the square root of 2 over 2. And the tangent is y over x, which are both the same number. So it's 1. And then over here, cosine of pi over 3, if you remember, pi over 3 is up here. Oh, great.
You might be able to undo. Oh no! I'm scared.
It's all right. It's all right. I'll just start over. So the tangent at pi over 3 plus the cosine of pi over 3. Okay. We already know this one over here is 1 plus the square root of 2 over 2. So I'm trying to work out this piece. So cosine, again, is that place right up here. And that has to be the square root of 3 because you go 0, 1, 2, 3. Right? 0, 1, 2, 3. So that means the sine has got the square root of 3, and that means the cosine has to be a half. And then the tangent has to be y over x. And y is the square root of 3 over 1 is the square root of 3.
I was so close.
Now, if I distribute my negative, then a half and that will make negative a half. Would everybody agree with that? And negative square root of 2 over 2 cannot be put with that because they don't have like terms. And square root of 3 can't either. But I can get a common denominator and make that 2 squared is 3 over 2. So they all have the same denominator. And then that would be my answer.
I was so close.
I was so close as well. I had a plus.
So we got to learn to distribute our negatives a little better.
Yeah, I just put the minus on the 2 over 2 instead of the square root of 2.
Yeah, it's so easy to just put one in the wrong place.
I know good and well which side is sine and which side is cosine.
But you put it
And I
backwards.
do it right sometimes.
Yeah,
In the second half of the problem, but in the first half, I did it wrong.
yeah. And I think that a lot of people are doing that. All right, number 9. Do you need that?
Yeah.
Did you divide first?
Eventually.
Yeah.
So that makes x plus 1 over x squared. Everybody agree with that? So if I integrate that, that's going to become x squared, so I'll put a half in front. And this is x to the negative 2, so if I take and add 1 to the power, it becomes negative 1, which makes that 1 over x. Right?
I'm doing that part right consistently in all of them.
Well, that's good.
And like getting to a certain point, and then it's literally just math that I can't do.
All right, so we got to put in 2 first. So 1/2 times 2 squared minus 1 over 2. And then minus 1/2 times negative 2 squared minus 1 over negative 2. So when you square 2, you get 4, and half of that's 2 minus a half. That's 3 halves. Sometimes it's better to do one whole parentheses, get the answer, which I think is what you were doing earlier when you said your stuff wasn't matching mine. And then negative 2 squared is 4, and half of that is going to be 2 again, but it's negative negative, so it's plus a half. And 2 plus a half is 5 halves. And then I use the subtraction sign between the two of them and get negative 2 over 2, and that's negative 1.
That was right.
Did I mark it wrong?
Numbers.
I don't know. It was like a strange half of an X, not a check mark.
Okay.
I couldn't tell if it was right or wrong. I was going for right.
Okay.
I was a negative away.
I think I did very
I'm a single negative away.
Yep.
I just plugged the numbers into the original formula and not the integrated part.
Okay, well, that didn't work.
Well, yeah.
You just had this symbol on it, Miss
It's
Shelton.
the,
So,
Okay, yeah, that was definitely a check.
and I was like,
Just
okay.
not long enough.
I was like, it could be either, but I'm just gonna.
All right, so
all in the right bottom.
this is the integration,
Okay.
and this is plugging the numbers in, because I ran out of room over there.
What?
Uh-huh.
I don't know, I'm getting the weird stuff wrong.
Okay,
Half of the stuff I should be getting wrong.
okay. That is kind of strange. All right, well then, do you need 10?
Negative error.
I got.
All right, well, first of all, you set that equal to 0, and that's 4. Everybody agree?
Yeah.
So that you can split your problem from 0 to 4 and 4 to 8?
I got this one. Wow.
Now, the 2 really doesn't play a part in the integration part, so if you wanted to, you could have brought that 2 all the way out here, or you put it on both of them. Then, if you graph this, this is your graph,
Oh, negative error. I want to make it.
okay? If you put 2 absolute value of x minus 4 in your calculator, it looks like this. This side has negative slope. So this is the one that had the negative slope, and this side did not. I think this is where we're supposed to be going. Well, and it don't matter when you put the 2 in, it gets doubled sometime. So if I integrate this, this will probably be easier to integrate if I distribute that, because then it'll become negative 1/2 x squared plus 4x. And I do that from 4 to 0, which means I just do 4 because 0 is going to be 0. So that's 16, I mean 8, that's 8. 16 minus 8, because it's half of 16 on that one. Over here, if you integrate, you get positive 1/2 x squared minus 4x, and you integrate that from 4 to 8. And you have to do all the math on that one because I don't have a 0 to plug in. When you do 8 squared is 64, divided by that's 32. 8 times that's going to be 32. That part drops off. And then when you put in 4 squared is 16, half of that's 8. And 4 times 4 is 16. That's negative 8 times a negative makes positive 8. And 8 plus 8 is 16.
I see. I just did.
Don't you have to double it now?
And so then, when I get done, I double it because I didn't take the 2 all the way through, and makes the final answer 32.
The problem was I knew what I was supposed to get because I couldn't even do a calculator. I was just like, I don't understand how to get there. And then I did.
Which is why I showed y'all the calculator, because I thought at least that way you'd know if you're on the right track or not.
But I realized I just did.
And so, every one of your problems almost, was it negatives?
No, not this one. I don't know what I did on
Okay. So a lot of negative errors and a little bit of problem with certain kinds of questions. Okay.
Negative error and math error.
Yeah, and we just don't add right, huh? Okay. Yeah, I'll come show you. Yeah.
When you graph the absolute value one, so like you keep like the whole like original problem like with the two with it.
Whether you do or don't will not matter in terms of getting the negative on the correct one. I could have left the 2 in here and left the 2 over there, and then I wouldn't have to multiply that 16 by 2 at the end. Or I can bring it out and just do it at the end. The less you put in there, the better, because it's just easier to keep up with it at the end. But some people forget it at the end, so it's up to you. You can even write it out here on each one individually if you'd rather. All right, anything else? All righty, well, we're going to move on to working on the bulletin board now.
And you're not